Example 7, Jack launches a small rocket from a table that's 3.36 feet above the ground. Its initial velocity is 64 feet per second. It's launched at an angle of 30 degrees. Okay, so real quick, we've got initial height, 3.36, and we've got initial velocity, 64 feet per second, and we've got an angle of 30 degrees. Okay, find the rectangular equation that models its path. So rectangular, when it says rectangular, we know that they're looking for x and y, right? So what they've given us is information that's good for a parametric representation. What they want is this rectangle. So parametric, we've got an x and y, x function of t, y function of t. Let's look at the x part. That x part is going to be set up as the initial velocity times cosine of the angle times t. And then the y part is going to be the initial velocity times sine 30 times t minus 16t squared plus the initial height. So what I would recommend you do is probably just type that 64 cosine 30 in on a calculator. We're going to get some square roots. We're going to get some crazy looking decimals. So let's just change it to decimal to make our lives easier. Okay. So 64 cosine 30 is 55.425 basically. I'm going to round off. I'm going to round off to about 4 decimal places. Okay. So what we want to do in this, in order to find a rectangular equation, is we want to solve one of the equations for t and then plug it into the other. Okay. Solve an equation for t and plug it into the other. So let's do that. We're going to take this one and solve for t. So I'm going to divide by that 55 number. We think about that as 1 over. So in order to isolate t here, I'm going to take 1 divided by my 55.4256 number. Okay, so I'm rounding up to 4 decimals, so I'm a little bit off, but that's okay. In this case, t would equal 0.0180 times x. Okay? So what I have to do is take that and plug that into the other equation. Plug that in for t. Okay? So take this and put it in place of t right there and there. We're going to have 64 sine 30 times 0.0180. I'm going to go ahead and do 64 sine 30 while I'm thinking about 64 sine 30 is 32. So that's going to say 32 times 0.0180x minus 16 times 0.0180x squared plus 3.36. Okay? Let's clean up just a little bit. I'm going to take 32 times 0.0180. And so right here I'd have 0.576x. And then I would have negative 16 times 0.0180 squared minus 0.0052x squared, and then plus 3.36. The only thing else I could do maybe is switch these two places just so it looks more like standard form. And I would have the equation y equals negative 0.0052x squared plus 0.576x plus 3.36. That's my rectangular equation. Okay. Now, if I hadn't entered this on the calculator, we'd have some square roots. There'd be a square root of 3 in there somehow. That might be more precise, but I think this will be easier for us to work with. So I'm going to be fine with you rounding off to 3 or 4 decimals like this. Okay. As far as what path does this follow, this equation looks like a parabola to me. Okay, so this path is going to be a parabolic path. Okay. It's going to look like an upside down parabola. And that makes sense. That's what we would expect a rocket to fly like.